tech lead here at Wix in Be'er Sheva, one of the first 5 programmers to join. And today we'll talk about decision making. Okay, so let's start with a small story. So I think a year and a half ago, something like that, I've been a part of a team which built a UI, and it was like a first project that we've done in React after like a couple of years of doing Angular. Like most of you, we've done that mistake. And you know, like, what is the first question every React developer asks themselves? Basically, we ask ourselves, which state management library should we use, right? It's like this holy, like, grail question that everybody asks themselves. And basically, it came down to 2, which are like the obvious choices. Redux by Dan Abramov, and Mobex by Mikkel, whatever his name is, Strasser, whatever. And like, it was like all of the team members, we came together and we started discussing which one should we use. But the problem was none of us had any React experience. Okay, we all came from different backgrounds, from Angular, from server, from whatever, ActionScript, and different kinds of abominations. So we decided to split up, do our individual researches, and then reconvene and basically come up with a decision. So we've done the research, we came together, but then we remembered that we work at Wix, which is like full of 2,000 plus brilliant people, and many of them did have experience with React and with either of those libraries. So we decided to gather like a council of people from all around Wix, from different like groups, and actually see what they can tell us, okay, from their own experience. But you know, like with everything in programming, we've received like so many opinions from all over the place, plus the things we've accumulated from research, that we decided that we need to somehow accumulate this data, and we created a decision matrix in order to help us make this crucial decision. And the problem was this whole thing took us over 2.5 weeks. And all the while, basically, we haven't written a single line of code. Okay, we just debated. And the reason for this was because to us, this decision was so critical because like, in our mind, there was no way we could build a React-based application without a state management library, right? There is no way. Moreover, like to us, this decision was like super crucial because there would be no way for us to revert this decision if we would have gotten this wrong, right? They are pretty much different and distant from one another. But we were wrong, okay? Because to this day, like I think the group I'm part of, we've built, I don't know, tens of React-based applications. And to this day, this remains the only one we used any state management library for, okay? And you know, like with every decision, right, that we need to make in life, to us there are only 2 options, right? We either are right or we are wrong. But the thing is that the pressure of getting whatever decision you're making wrong basically distracts us from the fact that we don't have any kind of information in order to make this decision. Okay, so today I'm here to tell you that given a situation where you're not sure whether the decision making is right and wrong, there's a third option, which is basically make no decision. Okay, you should basically postpone your decision, gather as much information as possible before you make this decision. Otherwise, basically, those decisions can have crucial impact on the software you're building. So what are we going to talk about today? First of all, we'll see several reasons of why you should be postponing your decision. We will then see examples of 4 things you can postpone while developing your software. Then I will present you like sort of like a mindset, one of them, that basically helps you decide whether you should postpone a certain decision and how you should be doing it. We will see things you can do in your code that will allow that, and then discuss costs of doing so. So let's start with the why. Well, I think, at least at Wix, most of tasks begin with some sort of architectural review, right? A design review, call it whatever you like. Hopefully you're doing the same. And the question is why is this the first step for most of people? Well, basically the answer is simple, because this is the meeting where we try to make as many decisions ahead of time as possible, right? And the reason for doing that is because we treat those decisions that are made there as crucial, because A, they are hard to revert, and B, the decision we make then will serve as sort of foundation which the whole software will be based on, right? You pick a technology or a language or a certain architecture. Basically, all the stuff you do afterwards is built on those decisions. And yet, with this huge, it's sort of like menacing, right? So, oh my God, everything will be based on those decisions. So, and yet, with all that being said, we're still beginning every project with making tons of decisions and stressing ourselves, like should we use SaaS or less? Which UI framework should we use? Should we use monolith or microservices? Which backend stack we should use? And on and on and on. But the question is, are all those decisions architectural? Or maybe some of them can be postponed and be taken way, way down the road. And the problem with early decisions is that they are not based on facts. So what are they based on? Well, they can be based on multiple crap. First of all, they can be based on biases. Okay, for example, you've had some experience with some tech or at your previous position and it didn't work out for you, and now you're totally against it and you don't want to use it anywhere else. It can also be based on hype. You went on Twitter, you read some blog, and now you're super eager to try this new thing regardless of the fact that it's basically a wrong tool for the job. It can also be based on ego. Right, we as developers are basically assholes, okay? Let's face this fact. And I'm sure many of you have been part of discussions where somebody argued for some opinion just to argue and just to win, okay? While themselves were not sure that it's actually the good way to go. As we said, early on, we don't have enough information to make any kind of decision. Moreover, I think we as humans, we are sort of okay in evaluating options that we are aware of, right? We're given options, we're evaluating, but what about things that you are not aware of, okay? Maybe there are options that you are not aware of, that haven't discovered themselves to you just yet, and they're actually way better than what you have right now on your table, okay? How many of you heard of Yagni? Okay, so cool. Nice. So Yagni is an acronym which basically stands for You Ain't Gonna Need It. This is sort of like a software engineering principle, you can say, which basically says that you shouldn't build stuff based on what you might need, but only build things when they become necessary. Now, this doesn't mean you shouldn't build flexibility into your code. This just means that you shouldn't do so based on assumptions. Okay, and the problem with this is that basically not only are you creating throwaway code potentially, but you're also building in complexity into your code, which you basically may not never utilize, but you will pay dividends on that complexity without even using it. Okay, and the following is an example of Yagni, right? This is a thermal exhaust from the Death Star, which some smartass built because he thought it would be a good idea, and it didn't really end up well for them. We love to npm install shit, right? This is Maven or whatever you're using. We love installing packages, right? Because it gives us this warm, fuzzy feeling of like I have a problem, I npm install shit, and then boom, the problem is solved, right? Like, how awesome is this, right? And now this thing that I said that would take me 3 days took me like, what is it, like 2 minutes to install whatever you like, and boom, the problem is solved. But I think like the problem is that we're ignoring what this thing does other than like solve this problem. We are ignoring the performance penalty, right? Because now your users need to download this crap, even if you're using like 1% of it. We're ignoring the onboarding complications that you've just introduced, right? You have a new team member joining your team, and now they need to learn yet another thing in order to be able to navigate your code. But I think the biggest problem with this is that you are not sure that you're actually picking a right tool for the job, right? And one of the reasons is this thing. This is called the hype cycle. You can look it up on Wikipedia, actually. And basically, this graph states that every technology, no matter like what it is, goes through different stages of hype. Okay, first of all, like nobody knows it exists. It's being erected. And then somebody like discovers it, blogs about it, tweets about it, and then everybody gets on the hype train, right? Oh my God, this is the Webpack killer, this is the React killer, this is whatever killer, this is the best, you should use it, blah, 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 blah. But eventually, as time goes along, people understand that basically it does not deliver on its promise. That it actually does not solve, it's not this like super mega library that solves every problem there is, and they abandon it, okay? And while it dwells in this like pit of disillusion, it's being either improved by the authors or the community, or it's being basically rediscovered by somebody else who actually finds like a more suitable use case for this technology. And only then, slowly but surely, after all this time, it actually becomes something that helps our productivity. Okay, so the conclusion here is that the more time you delay the decision to adopt some technology, the more confidence you will have that you're actually picking the right tool for the job. Scope changes are an unfortunate reality of our existence as developers, right? We build this amazing architecture, and then some asshole comes up to us and says, well, you know what, now I don't want this feature, I want it to go the other way, or whatever, and then this like art piece becomes useless. And the problem like with the fact that requirements change is that our architecture, our design, whatever we are making, its main purpose is to support those requirements, right? How do we make our software such that it's easily to apply those changes? Okay, and it's cheap. And if they change, basically we're optimizing our code for the wrong thing. So the conclusion here is that the more time you delay whatever decision you're making, the more time you give for those requirements to stabilize, and then you are actually have more confidence that you're optimizing your code for the right thing. Okay. So basically, given a situation where you're not sure where you're wrong or right, the best option you have is to actually postpone the decision, gather as much information as you can, and then actually make the decision. And as long as you don't make it after an optimal time and delay too much, this will be your least riskiest option. So now let's see examples of 4 things that you can and perhaps even should delay. Let's start at the very beginning. Okay, let's start with estimations. Okay, we suck at giving estimations, and for obvious reasons, because none of us are prophets. Okay, we don't have a gift or foresight, and we can't predict the future. That's obvious. And usually, what happens when somebody asks for estimations, we're like finger in the wind. Like, I don't know, I feel like 4 today. Okay, it's like 3. Like, we just throw out some random number just to get them out of our face, like away from our face. But the problem with those like random numbers that we throw out there is that they're fake. Okay, they're not based on anything. And those fake estimations evolve into fake deadlines, and those fake deadlines eventually evolve into late deliveries, and then we all suffer. So what we should do is we should base those estimations on some facts, okay, on something. Okay, and later we will see some stuff we could do in order to make our estimations more concrete. I love this quote. Okay, this is by Dan Abramov. If you don't know who he is the inventor of Redux, and he's like one of the core developers of React today. I think he was hired by Facebook when he was 17. Motherfucker. Anyway, so like, I love this quote, okay, because, and I agree with it, right? Because you don't go installing, like just like with glasses, right? You don't go buying glasses before you have trouble reading or before you started waving at random people, okay? Same goes for the libraries actually, right? You should first like encounter a need, okay, a problem, okay? You should then actually look in your code and look for existing solutions. Maybe you already have them. And even then, if you haven't found them, you should actually ask yourself whether or not it's a true need, or maybe you have a design issue. And I can tell you that in our case, whenever we encountered such need, the latter was true. We actually had a design issue, and some minor code changes basically removed any kind of need for such library. Abstractions, well, you know, like we as developers, we love making impact, right? We love to feel like we're making difference, okay? Like we're solving like world hunger and world peace and all that kind of crap. And one of the things we love is that we like to create abstractions which make our code dry, right? Don't repeat yourselves. It's like a holy grail goal that if you're doing it, you're an amazing programmer. But like the abstractions you're creating, are you sure that they're actually like solving the problem? Do you know if there are other people on your team who even have the same problem? Are you sure that it suits their needs? Are you sure that there are no existing solutions in your code? Okay, so these are all questions you should be asking before you're creating abstractions. Okay, and in my mind, one of the more horrible practices that front-end developers have that create horrible abstractions in many cases is this thing of smart and dumb components. Okay, those of you who don't know, back in the day, our Lord and Savior Dan Abramov, he posted a blog which says that every component, every React component or Angular component or Vue.js component, whatever you're doing, that you're creating, you should immediately split it into two. Okay, one that actually deals with all the presentational concerns, okay, like a drop-down, a button, whatever it may be. And the other that basically wraps around it, that basically handles all the side effects and, I don't know, logic if you have any, whatever. Okay, and the whole point of this practice was that it makes the UI component reusable with other data sources, okay? So instead of creating, I don't know, products drop-down, I'm creating a drop-down which I can put like different data sources into it and reuse it. But do you know for a fact that those components will be reused? Do you know how they will be used? Okay, can you like predict the ultimate API for those components? Probably not. And what I suggest is that you should not run forward and create those abstractions. You should wait. Okay, you should see how your code is being used, even if that means that it's being copy-pasted several times. And once you understand how it's being used, then create the abstraction, okay? And actually one of the rules, you know, like in programming, that I like to follow is the rule of 3, which basically means that you should wait for the third copy of your code before you create the abstraction, because then you will have enough understanding of how it's being used, okay? There is a nice blog about it, by the way, look it up. Server APIs. Again, it depends on the organization you work for, but in many organizations you have, you have a server developer and a client developer, and every task they have begins with them like meeting in some middle ground and then having a discussion of what will the API be between the client and the server, right? Mainly, they're discussing what will the response from the server look like, right? This JSON that comes in. But the thing is that this JSON, its main purpose is to serve the needs of the client, okay? That's its purpose, okay? And its structure need to be optimized for the needs of the client, one or many clients, I don't know. And the problem is that how can you create an optimal structure without the client actually existing, okay? I think it's pretty hard. Yuri agrees. So what I suggest is that you should postpone this decision, okay? You should develop your client, and after it's built, only then should you look at this, how it's consuming your data, how what would even the perfect view model look like, and only then decide on the API, okay? So hopefully, you're now convinced that you should be postponing your decision. But the problem is that, we as humans, we don't like to do it. Why? Because we don't like uncertainty. Okay? We don't like the uncertainty. And I think what would be helpful is some sort of a thought process. Okay? A thought process that, first of all, would even help us decide whether or not we should be postponing our decisions. Then it should help us decide when this decision should be made, and hopefully even allow us to revert the decision in case we are wrong. And today I'd like to present you one of those thought processes. Basically, it's called real options. It's a concept ported from financial markets, if you're aware of financial options. It's sort of like this, and it was ported to software engineering by a guy named Chris Matt. And basically, this is its rough definition, right? Real options are the right, but not the obligation, to take some action prior to expiration. Sounds complex, but I will give you an example that you are probably familiar with. You all travel, I assume, and you're booking a hotel. And every, hotel vendor and every hotel has an option for you to pay a little bit more in order to be able to cancel your reservation, right? Prior to some date, right? So what happens is that you are paying more in order to be able to decide later on whether you even want to go or not, okay? If you decide to show up, everything is fine. If you decide not to cancel and you don't show up, you basically lose the whole amount of money you have paid. And if you decide to cancel, it's either free or you are losing some minor fee, okay? But let's look at some examples that are closer to us as developers. Things like feature toggle and experimentation systems. There are many of them out there. I think Netflix have released one of them. Wix has one that is open source called P3. We use it all the time. Basically, the purpose of the system is to allow me as a developer to postpone the decision when a certain feature or a certain piece of code will be exposed to my users, okay? I can deploy things to production and they will not run, okay? Sounds like super magic, okay? And by the way, the whole point here is I can deploy things to production, and if I want to enable something, I don't need to go and redeploy stuff. I just go to some nicely looking system, turn true into, false into true, and boom, my things begin running. Okay? It also gives me a more complex option, which, for example, allows me to expose it to some people and expose something else to other people and then do an A/B test. Okay, so this basically allows me to postpone a decision. Also, things like rollout systems, deployment systems. We have one called Lifecycle, but again, there are many. Basically, they give me an option to postpone the decision whether or not I want to roll out my code to all servers or maybe or just to some of them. Okay, but because what they allow me to do is they allow me something called a partial rollout, which basically says that I can say, for example, Wix is running on, actually it is running on 5 data centers on multiple vendors, Amazon, we're using Microsoft, Google, whatever, all of them actually. And I can say, well, you know what? In order to be able to be more confident my stuff works, I will deploy it on just 2 servers in this data center, and I will monitor it. Okay? If things go nice, cool, then I will deploy it to everywhere, and things are cool. And in addition, it also allows me an option to revert my decision because I can roll back easily. Okay. So Chris goes on to define real options with 3 basic principles. Basically, that every option has a value. Okay. And it makes sense. Okay. I have a value in the fact that I can postpone my decision. Okay. It also has a cost, of course, but the amount of uncertainty determines this value. Okay. Also, each option has an expiration date. It expires. Okay. I cannot postpone a decision indefinitely because then I may lose valid options. Okay. So I need to define some sort of condition. It doesn't have to be a date even. Okay. It can be a condition that says that when this becomes true, I have to make a decision. And the third principle says that you should never commit error unless you know why. Okay? So basically your default, according to this principle, is to postpone your decisions unless you have a really good reason that you should be making now. For example, if the value of postponing is really low. Okay? If I'm making some decision and it's easily reversible, okay, or basically I have no value in like postponing it, then hell, I'll just make it now and be done with it. So what real options give us is, first of all, it removes the uncertainty, okay? Because instead of just saying, well, I will postpone it indefinitely and when I will make it, you are basically forced to define a concrete condition when you're going to make this decision, okay? It basically forces you and promotes you, okay, pushes you to gain more information before you actually make the decision. Yet, it also forces you to think whether or not you should even postpone this decision, okay? Maybe you should make it early, okay? So now, like in order to be able to postpone those decisions, we need to create an option for ourselves to do so. So let's see several examples of things that we should be doing in our code in order to create those options for ourselves. Let's start with TDD. How many of you know what TDD is? Okay. Basically, TDD stands for test-driven development. Basically, the whole premise is that you are writing tests for the thing you're building, and only then you're writing the implementation. Sounds weird, but it works. And one of the principles of TDD states that when you have a failing test, you should write the minimal amount of code in order to make this code pass, okay? I'm talking like the ugliest, simplest piece of code you can do in order to make this test pass, okay? And this basically forces you to make no assumptions about your code, right? Because you're doing it like step by step, you're not making any assumptions, you're just writing a minimal amount of code, which also makes you like YAGNI compliant, right? Because you're not building super complex things because TDD says that you shouldn't do it, okay? Okay, minimal amount of code. Also, if you're practicing outside in TDD, TDD basically has 2 flavors, outside in and inside out. Outside in TDD, I will not elaborate, but again, you can just Google it. Basically allows me to postpone a decision whether or not the thing I'm building now has any dependencies, okay? I'm not making any decisions ahead of time. And it also, even if I see that the thing I'm building has dependencies, it forces me to postpone the decision of how those dependencies will be implemented, okay? An example, okay, I'm building some component and I see that I need something that will help me, like, I don't know, make HTTP requests, okay, for example. So right now I'm focused on building this component of mine. I can then create some abstraction which will be in the future responsible for making the HTTP call, but I will not implement it, I will mock it, okay, create some stupid fake version of it, and that's it, okay? And then, like when I'm done developing my component, I can go inside and start implementing this thing and see how it will be implemented. And after, after the whole premise of tests, basically the whole point of tests, is that when all of them pass, now I have like a really good safety net which will allow me to refactor and return and revert my decisions, right? Because now I can safely do it, right? I have passing tests, and if I decide to change something and the tests break, I know that something is broken for a fact, right? It's not like I can, change something and then I go to deploy it to production and only then I discover that it's broken. Okay, so now I have like a really good safety net. Just give me indications that my changes are still valid and didn't break anything. Spikes. Okay, so spikes basically means that basically spike is a throwaway implementation. Okay, I'm talking the simplest, dirtiest, most dumbest implementation you can find. Okay, now why is this cool? Imagine that you, for example, need to give an estimation or something. Okay, and you know for a fact that part of your task is integration with some system. Okay, now naturally what we usually do is we just throw out some number, okay, we just throw it out. And I was part of such project where integration took a lot of time, okay, because you're integrating with some third party, you have no idea how it works. And spikes come really handy here, right? Because before you give this estimation, okay, you can go ahead, create some simplest, dirtiest code that implements with this third party. You gain understanding of how it works, and now you can give estimations which are way more concrete, okay, and way more like truthy, okay. In addition, it can also be helpful when you're like considering adopting some technology, right? Because instead of just adopting it, you can take this technology, okay, and you have a problem that you're actually facing, then you can use this technology to create a really naive, simple solution for that problem using that technology, and then you will have way more confidence that you're picking actually the right tool for the job. Something else that is helpful is something called the ports and adapters architecture. It has several names and representations which are more or less similar: hexagonal, onion architecture. This actually comes from a great book by Ned Price. Basically, the whole premise of this architecture says that you should divide your code, all of your code, into two categories. Okay, like imagine two buckets and you're like putting it right and left. And basically the first category is your domain logic. Okay? This is where your like solution lives, okay? Your domain logic, okay? All your business entities and all your algorithms and all that kind of crap, okay? And this has there is nothing here that speaks about the technology you're using, okay? This code does not contain React, it doesn't contain Redux, Axios, database, nothing, okay? Pure logic lives here, okay? And what contains your technology is basically this thin layer, which is basically an abstraction, a layer that contains the abstractions that talk to that make the HTTP requests, they basically wrap those libraries. This is the abstractions that talk to your database, okay? And what this gives you is two things. First of all, it allows you to create this inner part, okay, most of your application, without making any decisions about the technology you're using, okay? And once you've done that, okay, when you made the decision, you decided the frameworks you're going to use, you can replace them easily because now you have you're not talking to them directly in most cases, okay? Of course, there are outliers, okay, like React and all that kind of stuff. You have abstractions that allow you to swap out those technologies without most of your application being even aware of the change. Frameworks, but frameworks are cool, right? We all love them. The frameworks, mostly because they give well-defined, well-packaged solutions to low-level problems, okay? And they allow us to basically focus on writing our application-specific code, okay? But they come at a cost. We discussed some of those costs early on. And I'm actually here to suggest that before we adopt a framework, we have other options. We don't have to go all in. We can start by actually borrowing concepts from those libraries, start using those concepts and abstractions, and only then actually decide whether we want to adopt the whole thing. And let's see an example. How many of you are familiar with Redux? Okay, many of you. Those who are not a biggie. It's super simple. Basically, the way Redux is a state management library for client applications. Never mind the framework you're using. And it goes like this, right? You have a UI component. When you click or interact with it, it uses a function called dispatch in order to fire some event. Okay, this event is being passed to a function called reducer along with the previous state of the application, which is represented as a single object. And this function returns a new state of the application, which is then given to the components to be rendered. Okay, super simple. That's it. Let's look at the reducer, which is the function that produces the application state. Super simple. JavaScript function receives the current state of the application, receives the event that we've just fired, and based on the different parameters, the event and everything and all that kind of stuff, returns a new state. Okay. There are concerns of immutability. Actually, shameless plug, you should wait for Roy's talk. He will actually tell you, implement this thing from scratch, which is amazing. So now let's look at a simple React component. Again, that uses it super simple, okay? React component, nothing fancy. It basically shows a value, and we have a button that decrements this value. We have a decrement function here, which is a simple callback. And this is where things get interesting. Remember the dispatch function that we said that Redux provides us that fires the event? So what we can do is that we can not use the Redux's version, and we basically can implement dispatch ourselves inside our component, okay? And then we can use the reducer, which used by Redux, in order to create the state of the application, of this component, okay? Now the cool thing here is that we are not adopting the whole Redux. We are adopting and enjoying all the benefits that it gives us, right? The separation between state mutations, in easily testable code, and all that kind of stuff. Yet we're not adopting the whole thing. And in the future, if we decide to actually pick up Redux, it will be super simple, right? Because we already have the reducers. Our components are already using the same dispatch function, which adheres to this exactly same interface, okay? And it will be relatively cheap. All good things in life, unfortunately, postponing decisions has its costs, and we need to be aware of those costs. Let's explore some of them. First of all, as we discussed earlier, postponing decisions too much can eliminate important alternatives, okay? Again, there are, in fact, some decisions that you should take early on, okay? And if you will postpone it, it can cost you. It can also eliminate alternatives that are actually very viable. It can also put others in the bind, okay? If you are a sole decision maker, or perhaps you are part of the team that makes the decision, in many cases, you are affecting people and teams that you are not even familiar with, okay? Especially if you are creating some system or a platform that others need to integrate with. And if you are postponing some decisions, you are making other people stuck, okay? In your team and in other teams as well. As you've seen, in order to be able to postpone decisions, okay, we need to make our system flexible, okay? We need to make parts of our code flexible, which unfortunately also always introduces complexity into our code. And if you make everything super easily changeable, everything becomes super complex. So this is a really high cost, so we need to be aware of that as well. And it also increases mental load, right? If you're postponing too much decisions, you have too much decisions hovering over you that you need to make. And in many cases, unfortunately, this is our nature as human beings, we will make just random decision just to get rid of the, the stress without even thinking about it, just to get rid of it, okay? So to summarize, first of all, by default, you should really consider postponing decisions while developing. Okay? You should never commit early unless you know why. As Chris Matt says, and in order to be able to postpone those decisions, you need to create options for yourselves using the tools I've mentioned, the TDD, and whatever it may be, or other tools. And of course, unfortunately, you also need to be aware of the costs. Mainly, like if you're like thinking in real options, when you're like calculating sort of the value of an option, or like you're creating to postpone the decision, you need to also think about costs while doing it. Like maybe there is a value in postponing the decision, but the cost is really high, so like the value is low. That's it.